All right. Well, hope everybody had a good weekend. We are now officially in the second 6 weeks. We've survived our first, only five to go. So always glasses half full kind of thinking there, try to be positive. But I do want to go ahead and start thinking more big picture, as I like to call it, because your semester grade is going to be determined by your 3 6 weeks grades and our final, and we've already got 1 6 weeks, locked in, and it's, staying constant. So we want to be looking, the second 6 weeks, third 6 weeks, just kind of thinking about, our 6 weeks grade. Andre? There we go. Okay. So, again, if you have any questions, please, I'm here in the morning, 7:45 to 8:05. Come on in. If you want to come in after school, just to give me a heads up beforehand. I'll see if I can arrange things for you to come in. But if you have any difficulty, let me know. I want to help you out. I want you to feel successful in here. So there's a few things before we go ahead and get started, because it has been quite a few days since we've actually been able to talk. Friday was our district assessment. We didn't get to interact that day. But I've listed all these on the board so that I wouldn't forget about them. So if anybody is in an upper level class, such as this one, and you happen to have failed the first 6 weeks, if you're needing a waiver for some kind of activity, sports, whatever, those are due to Marcia Edwards, Mr. Young's secretary, by 10 a.m. Friday. Okay, you can go in there and just get one of those, fill it out, get it taken care of. Or if this for any other class concerning you. We have a tornado drill coming up on Thursday, the 27th at 9:15. So it's going to be during our second period class. So hopefully your teachers are going to start talking to you, or have already talked to you, about where you should go in case of a severe weather emergency. Now, let's say a tornado drill or a real one happens to occur while we're in here. Do we know where to go? That's exactly right. Now, in a fire, of course, we're going to go down these stairs, right out the exit by the nurse's office to the sidewalk where there will be buses waiting to take us to a secure location. But in a severe weather emergency, we don't want to go outside. We want to stay inside. So we're going to go down this 1200 hall right below us, past these computer classrooms, and right down there at the end on the corner across from those vending machines, that's where the art office is. So on the first floor, the main floor hallway, right there on the corner by the art office, that's where we want to go ahead and meet up, right next to those vending machines. So, we always want you, we're asking that you face the wall. We know it's going to be kind of uncomfortable. We want you to go 3 or 4 deep. We're going to try to fit everybody in the school on that main floor. We want to get a path in the middle just in case an administrator or a teacher has to go up and down quickly and go ahead and give you guys some instructions. So any questions on where we're headed, if it happens during fifth period? Hopefully second period, your teachers, like I said, are already kind of mentioning. Has anybody, your second period teachers, brought it up today? Yeah. Okay, good. If they haven't, they'll probably be doing so in the next day or two. But that's on Thursday. We're required by law to have so many a month, and, we got to practice. You got your next quiz on Thursday. Your homework that you got last week is going to be due tomorrow. In fact, we will have time today in class to go ahead and work on it. We could probably work a couple of examples together. I'm perfectly fine with that. But the quiz on Thursday will be over that material. It's going to be over inverses. Okay, so what we finish up with today. So this week we're already going to have at least 2 or 3 grades, going in the grade book. Okay, so we're starting off really well. And it's not too early to go ahead and start mentioning this. 2 weeks from today, on October 8th, we're going to have our first exam of the 6 weeks. So it'll definitely cover inverses. It'll probably have some factoring on there. We're going to take a couple of days this week to go ahead and practice that. Should kind of sharpen our skills. And then near the end of the week, we are going to start trigonometry. We're going to start our trig unit. So there's some definitions we want to talk about, then we'll start applying them. But you can kind of expect that kind of stuff to be showing up on the test. And that's going to be kind of an unusual week anyway, because what's happening on that Wednesday the 10th? The PSAT. And I don't know the schedule. I don't know if I will see you guys that day or not. Probably not, but I don't know as of right now. There's trainings going on next week, so they're going to let us know exactly what's going to happen. And as I get information, I'll let you guys have that information as well. But are there any questions about any of the bullet points I have up on the board? Test in 2 weeks, quiz Thursday, tornado drill, waivers, or anything else anybody has a question on? Okay, well, let's get to it. We only have a couple problems left on our notes. And if you do need a copy, if you've misplaced it, there should be some right over there in the filing cabinet by Adolfo. Okay. I believe it's Thursday when we started talking about those, Wednesday or Thursday, but the notes are there, as are some copies of the homework assignment. Okay, so given a formula for the function f, find the inverse by. 1, determine if an inverse exists. That is, check that f is 1-to-1. Ask yourself, is it necessary to restrict the domain to get a 1-to-1 version of f? Well, how do we test if it's 1-to-1 or not? What's that test we're talking about? Starts with the H. The horizontal line test. Just like we test if it's a function using a vertical line test, the horizontal line test tells me if any values of y repeat. If it is 1-to-1, you are guaranteed your inverse is a function. You don't have to do anything. But we like our inverses to be functions. So if your original graph is not a function, we have to restrict it in some way. We have to cut loose some values of x so that we do have a 1-to-1 function, and we get that. And I'll show you how that works. Okay, 2, interchange the x and the y in the formula. Switch the positions of x and y, just as we did last week. Number 3, solve for y to get your inverse. And then because it will be a function, we'll replace y with its notation. Now remember at the beginning of the lesson last week, I want to say it was 1b, we came across a problem that was an inverse relation. I hadn't yet at that point shown you how to restrict the domain. So at that point we left it equal to y, but now we're going to want to make sure that our inverses are functions. Okay, so let's look at this example here. Okay, for each of the following, it says sketch the function, find the inverse, sketch the inverse, and verify that they're going to be inverses algebraically. Okay, so you'll notice over here, I've already got this line. What's the equation of that line? Y is equal to x. That's my linear parent, right? Okay, so why is that important to inverses? What does he represent? Well, he is a linear function, but he's the line of symmetry. That's exactly right. If I have a graph like this one here, 2 minus x squared, and I want to go ahead and see what the inverse graph looks like, if I reflect anything across y equals x, the result is going to be the inverse, whether it's a function or not. Okay, so let's see. It looks like we're dealing with a parabola, 2 minus x squared. So what direction would the parabola open? Down, okay, because the x squared is negative, so that would result in a reflection. What's that 2 going to do to it? It's going to shift it up 2. Okay, so I'm going to have a downward opening parabola. Now, if you were to set him equal to 0, you'd be able to solve for your roots, and I'm going to tell you they're going to be about roughly 1.41. So that's not really important, but if you just wanted to make your graph a little more accurate, it would probably look something like this. There's the graph of f. Okay. Now, let's go ahead and reflect it across y equals x. Now, remember, if you have a point on the graph, and I want to know what that point would look like on its inverse, well, what do I do with those? All you do is switch them. Like, for example, this vertex right here, we see the vertex is at 0, 2, right? So what would that point look like on the inverse? It should be 2, 0, okay? We don't change their signs. We leave the values as is. We just switch their positions. The x becomes the y and vice versa. So I know I'm going to have this point right here at 2, 0, and it's probably going to look something like this. Okay. Well, I'm looking at this graph, the parabola that just opens to the left, and I'm already seeing, while he's the inverse, he is not going to be a function, right? Because he's not going to pass the vertical line test. Well, let me go back to the original graph. Okay, this downward opening parabola. What do we know that would have already told me the inverse is not a function? Yeah, the horizontal line test. I'm looking at this guy right now, and if I go ahead and put a horizontal line through him, except for the vertex, every place I put a horizontal line, he's touching it in 2 places. So I know that this inverse is not going to be a function. So let's start here. What's his domain? Okay, so even though this guy's opening down, he wants to be infinitely wide, right? So we're going from negative infinity to infinity. Let me take this off right here. What's his range? Okay, so negative infinity to 2. Bless you. And the 2 would be included, right? Now, here's the thing. This is what the problem is talking about. Because this is not one-to-one, okay, I know that my inverse won't be a function. So if it's not one-to-one, we have to go ahead and decide how we are going to restrict his domain so that he will be one-to-one. Okay, now there's really no right or wrong way when you're deciding about this. Me personally, when I'm going to go ahead and restrict a function, I tend to go to the right side, the positive side. So this domain right here, the negative to positive infinity, that's not going to work, okay, because he's not one-to-one. So I'm going to restrict him by simply cutting off half the parabola. So I only want him to exist from 0 to infinity. See, I'm restricting his domain. Okay, that's what we say. Basically, you're just cutting loose part of the graph, losing some x values, so that if I did put a horizontal line through there, he's now one-to-one. And if he's one-to-one, what do we know about the function? The inverse is going to be a function, yes. Now, here's the thing. If your graph is already one-to-one, you don't have any worries. You just continue with the problem, you're good to go. Now, there's probably some folks out there who are thinking, well, why choose the right side? I mean, does it really make a difference? No, it really doesn't. I mean, if we had this guy here, the graph that we're looking at, I could just as easily have said, you know what? I want to keep the left side and cut off the right side. Now I'm just saying his domain is from negative infinity to 0. But is it still one-to-one? Yeah. So it's going to slightly change what your inverse looks like, but there's no right or wrong way. As long as you get a graph that's one-to-one, you're perfect. And like I said, that's why I kind of prefer just to go to the right side. There's no specific reason. It's just what I've always done. Okay? So I want you to know that even though if you went to the left, it would still be okay. All right. So now that I've restricted his domain, I've made this guy one-to-one, well, let's go ahead and figure out what the inverse is. Okay. How do I do that again? I keep forgetting. We switch the positions of x and y. So now I'm going to take this off because he is one-to-one. So instead of y equals 2 minus x squared, I'm going to say x equals 2 minus y squared. Okay. And now I just solve for y. Okay. So how do I do that? What would I do first? Okay, so let's subtract the 2. So minus 2, those cancel. So x minus 2 is equal to a negative y squared. Now what? There you go. Before our last step, in order to make it just y, we take the square root. We got to make sure it's a positive y squared. So I'm just going to go ahead. We can multiply or divide through by a negative 1. So this would be negative x plus 2 is equal to y squared. Now I'm going to take the square root. But here's the thing. You remember when we're solving algebraically and we take a square root? What do we put in front of it? The plus and minus. We don't want to do that here because the negative is going to give me the reflection. That would give me a full parabola, right? Remember, we restricted this guy so that he's only half of a parabola. So I end up with the square root of negative x plus 2. Now, think about what that last step on the previous page was saying. Did we guarantee that this inverse is a function? Yes, this is an inverse function. So my last step is to take the y and replace it with the inverse notation. Remember, I can only do that if what I come up with is an inverse. Okay. Now, let's do something really cool. I know what you're thinking. Wow, everything we do is cool. But yes, let's talk about his domain and range, and then we look at his graph. Remember, what's the idea for the x's and the y's in an inverse? We do what? We switch them, right? So this inverse's domain should be the range of the original function. I'm just taking the domain and range, and I'm going to reverse them. So this guy should be negative infinity to negative 2, right? His range should be the domain of the original function. I'm sorry? Oh, I'm sorry. I was, again, just saying if you were paying attention. And obviously, Brandon, I can't trick you. And for the range, we got 0 to infinity. There we go. Now, let's go ahead and reflect this guy across the y equals x line of symmetry. Okay, so we know that 0, 2 is going to be at 2, 0, so it's probably going to look something like this. Okay, remember, I'm not the best, artist in the world. Yes, Angel. Oh, true, true, true. But remember, we're talking about how high he is, right? So the fact that he's opening to the left doesn't matter. All of these are representing positive y values, right? So we are height-wise going from 0 to infinity. Okay? And take a look at his domain. He's curving to the left. Does he go from negative infinity to 2? Yeah. Okay. There you go. So only if your original graph is not 1-to-1, you'll decide how am I going to restrict him. If he is 1-to-1, no worries. You just find the inverse. Now, there's one other thing these problems wanted me to do. It said verify that they are inverses algebraically. So let me show you what I mean when we say that. The original function was 2 minus x squared, right? Okay. So f of x was equal to 2 minus x squared. The inverse that we just found was the square root of negative x plus 2. Okay. Well, this is why we went through the previous lesson on compositions prior to this. We need to show that the composition will simply give me x. I need to show that f of f inverse of x will give me x. And I need to show that f inverse of x will give me x as well. And why do you think x is important? Why does it have to simplify to x? Remember, what's our line of symmetry? It's y equals x. Okay? So this isn't where we're going to plug in a value. This is where I'm going to take the actual equation and I'm going to go ahead and plug it into the other one. Okay, just like we did in the previous lesson. Is everybody okay so far? Okay. Well, let's see. 2 minus x squared. Okay. But instead of x, I'm going to replace it with this equation. So 2 minus x squared becomes 2 minus, we have this radical, negative x plus 2 squared. Well, what's going to happen when you square a square root? They cancel each other, so they're gone. Don't forget, I have to distribute the negative across those parentheses. So what's a negative times a negative? So that would be 2 plus x, negative times 2 minus 2. And what do you notice? The 2's cancel, see, I'm left with x. So see, it's looking good, okay, but we're only halfway there. Remember, you have to show it both ways. Is it possible that it could work one direction but not the other? Yes, absolutely. So you always, always want to check. So now we got that one taken care of. Now I'm going to reverse it. I'm going to take this function and I'm going to replace that x with him. Okay, we're just going to do the exact opposite now. Is everybody okay? So I've got the square root of negative x plus 2. Okay, but instead of that x right there, I'm now going to replace with f. So I've got the square root. Negative x becomes negative 2 minus x squared. And then we still have a plus 2 inside the radical. See, all I did was replace x with the other equation. Okay. Now, this time, we have to simplify the inside, the radicand, before we get to the radical. If I distribute the negative, this is going to be negative 2, what? Plus x squared plus 2. Well, you'll notice, again, the 2's cancel. And what's the square root of x squared? X. There you go. So this proves that these two are inverses. If you can take their composition both directions. And the one thing about it, it has to be x. Any variation of that, even if we had simplified it down and you got negative x, even that negative was enough to tell me I can't say they're inverses. It has to be just one positive x, and that's it. How we doing? Okay. Well, let's practice another one. Let's do another one. Okay. This one's function g, the cubed root of x plus 2 minus 1. Okay. Well, think about the parent cubed root. What's he look like? The cubed root of x. What's that, sir? It is a squiggle. In fact, it looks like what letter just stretched? It looks like a stretched S. Okay. So the cube root of x, well, let me go ahead and draw it. It's definitely going to go through the origin. Let's see how well I can draw this. It's going to go probably look something like that. Like a curvy S. It's going to go through the origin. The parent will go through the point 1, 1. And it'll go through the point -1, -1. Okay. But now, this one, while it's based on the parent, what are two transformations you notice? Down 1 and to the left 2. There you go, because we've talked about the transformations before. So this point right here at the origin, he's going to go 2 left and 1 down. So 0, 0 should become -2, -1, right? Would you guys agree? So this is what the function looks like with the transformations. And you can put that in a calculator if you wanted to kind of confirm that. Okay. Well, first off, is he a function? Would he pass the vertical line test? Yes. Now, more important, would he pass the horizontal? Yes. If I put a horizontal line anywhere through this graph, it is never going to touch that curve in 2 places at any given time. So here's why this problem is really nice. If he passes the horizontal line test, I know this guy is 1 to 1, right? But more importantly, I know that the inverse will be a function. See, I don't have to do anything like I did on the previous problem. I don't have to restrict his domain. It can stay as is. We just find the inverse. Okay. So how do I do that again? I keep forgetting. Yeah, switch the x and the y. So x equals the cubed root of y plus 2 minus 1. Okay. So walk me through the process. How do I do this? Okay, so first I'm going to add 1, plus 1, plus 1. Those cancel. So x plus 1 is equal to the cubed root of y plus 2. Well, now there's something I got to do before I subtract 2. There you go, because right now he's being protected by the cube root. So to get at the 2, I'm going to go ahead and cube both sides. So this time I'm going to cube this quantity. So x plus 1 cubed is equal to the cube and cube root cancel, y plus 2. And now I can subtract 2. Okay, so I'm going to say x plus 1 cubed minus 2 is equal to y. Now, I know that 1 minus 2 would give me -1. Can I go ahead and do that? Now, I would have to go ahead and simplify the cube if I wanted to start collecting like terms, so I would just leave it like that. Okay, now remember our last step, because we know he's a function, I'm going to replace y with the notation. So we're talking about function g. So I'm going to replace it with g inverse. Okay. And in fact, let's take a look. For example, this point right here, -2, -1, what would he look like on the inverse? -1, -2. Remember, we don't change the sign. We just switch the values. So let's see if I can make this look anywhere like it's supposed to. That. Now, think about this for a second. What does x cubed look like? What 2 quadrants? There you go. Christian's drawing him in the air. He just curves up to the right like that, right? Well, does this graph look like x cubed, 1 to the left and 2 down? Yeah. It's symmetrical about y equals x, so we're good. Now all we got to do is just show the composition. Okay. So let me write these out again. G of x is equal to the cubed root of x plus 2 minus 1. And then for its inverse function, we found x plus 1 cubed, and then minus 2. Okay. So let's say I want to take this first. G of G inverse of x. This composition just proves to me that they're inverses. Okay. So which equation will I plug into the other? G into G inverse or G inverse into G? The way I have it written, the inside function is going to go in here. Okay. So let's see what we got. Instead of the cubed root, I'm going to make this a big radical. Instead of x right here, I'm going to replace x with this inverse. X plus 1 cubed minus 2. Now remember, that is just the x. Then we have this plus 2 right here. And then outside we have a minus 1. Just like we did on the previous one. I'm substituting one equation directly into the other. Well, what do you notice immediately? Okay, well, the 2's are gone. What's the cubed root of a cube? Those cancel. So it looks like I have x plus 1 minus 1. And when those cancel, see, there's my x. All right. So there we go. I mean, that should be enough to show their inverses. There you go. You have to do it both ways. Okay. It's very possible it could work one way but not the other. Now, I'll go ahead and ask you guys this question. G inverse of G of x. Okay. Now I'm going to take this equation and I'm going to plug it in the other guy. So, spoiler alert, I'm going to go ahead and tell you that this will work. Does anybody want me to actually do it? Does anybody want to see it? Not really? So Lilibel's okay? Does anybody want me to go ahead and do that? Okay, we've got a head shaking yes, so let's do it real quick. So let's see. Instead of the x plus 1 cubed, so I have this big parentheses right here. So instead of this first x, I'm going to put in this. So the cubed root of x plus 2 minus 1. So that right there is just the x. Then we have that plus 1. And now we have the minus 2. Okay. Well, what do you notice? What immediately drops out? Okay. Negative 1 plus 1. Now I'm taking a cube root of a cube. So again, those cancel. So it looks like I have x plus 2 minus 2. There we go. And that's it. Now, if either one of these, like if the very first composition does not give me an x, do I even need to worry about the other composition? No, you can stop right there. You can immediately say, nope, they're not inverses. Okay. All right. And that is it. That's inverses. So let's do this. With the time we have remaining, I've got the homework snapshotted up here. I believe there are extra copies over there, again, by Adolfo in the filing cabinet, if anyone needs one. We're going to be turning these in tomorrow. Is there any problem on there you guys are looking at we need some help with? Well, let's narrow it down a little bit because we have until 36. So it looks like we have about 12, 13 minutes. Yeah, since we're on the homework, you can go to the bathroom. Okay, right over there. Yes, let me go ahead and get you on that exam. And did anybody else who's been absent want to go ahead and start that exam now, or? Yes. Christian, you want to go ahead and do that? Okay. There you go, Christian. Sure, if you want to. Marcus, did you want to do that, or do you want to wait? Wait, okay. And Deborah, you want to go ahead and do it? Okay. Oops. There you go. Okay. All right, so what do we want to look at for the homework? Number what? 5. Okay, so let's take a look at 5 through 8. Now, these right here, the way the instructions are written, these are just going to come down to yes or no questions. Okay? So like this first one out here, number 5. Use a graphing utility to graph each function. and use the horizontal line test to determine whether the function is one-to-one and has an inverse. So they're not asking you to find the inverse yet. They just want you to go ahead and say yes or no, is this one-to-one? Well, let's see. It looks like we have a quadratic here. In fact, do you guys remember the vertex form? Can anybody tell me what the vertex of this parabola would be? Or just think of it in terms of transformations. Okay, -3, -4. He is absolutely right. Our vertex would be at -3, -4, because we go 3 left and we go 4 down. Now, that 1/2, that's a dilation, right? A vertical dilation. Is that a stretch or a shrink? That's a shrink. So is that going to make for a skinnier or a fatter parabola? Probably fatter, because it's half of what he originally was, right? Now, if I were to stretch him, then he gets skinnier. So let's see. I remember I'm just sketching these. So 3 to the left, 4 down, and we're probably going to be looking at a fatter graph. There you go. So yes or no, is this function one-to-one? No, it's not, because he fails the horizontal line test. In fact, if I put a horizontal line, I'm going to touch him twice. So I'm just going to go ahead and put no. That's all you do on those 4. Okay. Now, in some of them, if you're having trouble, like if you don't know -x square root of 9 minus x squared, we can kind of investigate it and analyze it, but I'm okay with you just using the calculator and getting the sketch if you want to. Okay, so that's 1 down. What next? Four? Okay, so let's see here. 4, for these 4, it says sketch the graph of the inverse function for each function shown, and then state the domain for each. Okay. So let's say, and of course, you have to go ahead and believe that, these guys are going to continue past what we see. We're not just going to go ahead and stop there. So let's call this function f, or you can call it whatever you like. What's the domain of f? Hello? Yeah, it's all reals. Even though these 2 parts here are very nearly vertical, slowly but surely they are going to be pushing out in both directions, right? So for f, okay, the domain is going to be negative to positive infinity. Now, what's the line that we go ahead and reflect these across? Y equals x, right? So there we go. Here's y equals x. So what's this going to look like? If I were to reflect this one over this way. Now remember, I'm not the best artist, so it's probably going to look something like that. I could do better. Probably going to go meh. Like, does everybody kind of get the idea? Yeah. I mean, it's going to look like there's a little twist tie right there in the middle of the graph. Okay. All right. In fact, it makes sense because it looks like f is x cubed, so the inverse would be the cube root of x, right? Okay, that elongated s that we were just talking about. Well, this one's easier to see, so this would be f inverse. Well, what's his domain? Yeah, he's still all reals. Negative to positive infinity. There you go. And that's all they want you to do on the first 4. That's all you got to do on the first 4. That's it. Just reflect it across y equals x. Tell me the domain of each, the original and the inverse. See, I'm not even having you find the inverse yet. Okay.
So we only have to say like the regular domain?
Yeah, a regular domain and the inverse domain.
Okay.
Mm-hmm. Mm-hmm. Okay, well, I would look at it after you sketch it. Like, choose another one. Number 1? Okay, so this looks like, if I were to say, it looks like 2x minus 1, because we're crossing at a -1. Looks to me like I would go up 2, right 1. But the actual function itself really isn't necessary. I just want to go ahead and reflect it. Okay. So let's take a point. Like this point right here at 0, -1. What would he be on the inverse? He'd be -1, 0. So if this guy is f, it's probably this guy right here would be f inverse. We're just finding the inverse by reflecting it. Now, looking at the graph, okay, well, how wide is f? Yeah, he's all reals. What about his inverse? Again, he's all reals, yeah. Okay. Now, will that be the same for 2 and 3? Now, that's where you're finally going to start to see a difference. Okay. So there you go. You just have to put the domain for each. No problem. We still got time. Do we want to do another one? Which one? Let's see. We got some word problems. You got some composition problems. I'll go ahead and tell you that on your key, I randomly chose 10 problems. So you won't be grading all of them. Just at least one from each section, yes. Okay, so did I hear someone say 21? 21. Okay. Is Vine even still a thing, or is that?
Vine died, but I still watch them.
Okay, so it's good. No, they are not producing any more Vines. Okay. Music took over.
Musically.
What does that mean?
Big lip sync.
Oh. Hey, do that again? So what do you like? Dancing like someone in a music video, or?
No, it's like audio clips. You lip sync, or you like lip. Hi, how's it going?
Yeah. Okay.
And
Oh.
sometimes it's like this, and it's weird.
Okay. Interesting.
Some make millions of dollars.
Yeah, a lot of them, like some of them even branched out into like the entertainment industry, movies and stuff. Like, well, I don't know his real name. Was it King Batch?
Fine.
Yeah, he's been in a lot of movies. Also, the one I like, just because they're the only Vines that I could actually show in school that's not completely inappropriate. Who's the guy who does the Disney pranks with friends?
Oh, Thomas.
Yes, I like that. That guy's funny. I like him. Okay. Anyways, let's go ahead and work on 21 before you guys get out of here. Yeah, and he does those like puns and stuff. I guess that's why I like him, because he's the guy who can do the really good Stewie voice and the old man voice from Family Guy. Yeah, there you go. There you go. Yeah, that white dude. Okay. All right, in June 2015, you're planning a trip to Japan and find the exchange rate for converting US dollars X to yen Y was Y equals 123.65 X. How many yen could you get for $100? Okay. Well, 100 US dollars, that is representing what? The X or the Y? That's the X value, right? So for A, I'm simply going to go ahead and plug this in. So Y would equal 123.65 times 100. Now, we probably don't even need the calculator for this. If you multiply by 100, what effect will that have on the decimal? It's going to move it to right. So I would be able to get 12,365 yen. So 100 US dollars would be 12,365 yen. Okay. Now it says, what is the inverse function and what conversion does it represent? Well, here's my equation. So remember, what do? We switch the x and the y. So x equals 123.65y. And now what do? Yeah, just solve for y. So in this case, all I'm going to do is divide by 123.65. Okay. So y is equal to x over 123.65. There you go. There's my inverse. Okay. So unfortunately, we didn't get a chance to finish, but if you do have any more questions, I'll be here in the morning. just come on in. I'll help you out. Okay, we'll grade this tomorrow first thing, and then we'll go ahead and move on. All right. Thank you guys very much.